Alright, another draft physics video presentation. Simulation, one of them. It looks pretty cool. Not exactly sure of the rules. It's been a slight modification, and we'll see. But the basic principle is the same. A certain amount of energy is going in, and as you can see, it doesn't catch fire, it doesn't blow up, the universe doesn't end. You know, all these arguments about how particle model can't explain, and it can. You know, 2 plus 2 plus 2 kind of thing can explain it. But it's subtle and complex because there's two worlds that exist, kind of the high pressure world inside of suns where, you know, atoms are made, and the less pressure world where they survive and combine, and the chemistry that, you know, we're the byproduct of, and all of that. But the principle's there. I'm just saying, you know, look at it. You know, it works. Basically, all you need is electrons and protons and two forces, and you know, the whole thing falls into place. Two interactions, maybe three interactions, but you know, I think it's just two. But anyway, yeah. So I'm just saying, it's this argument that conventional physics makes that nothing else can explain it. You have to believe in this wavy, entangled, superimposed, magical crap because we have no alternative. There's no alternative reasonable explanation. You know, it has to be a god. And, you know, there is a religion. It's full of, you know, just a bunch of, as some people complain, unfalsifiable, made up stories. That you can't even imagine in any kind of coherent way, where mechanically this is as simple as it gets. Push everywhere, and you just get hit by stuff. And depending on what stuff you get hit by, you react differently. But there's only really two choices. So anyway, I don't know. Like I said, all I can do is reason with you people. If you won't be reasonable, then yeah, I'm sort of out of luck. We're all out of luck. It really, you know, the whole future depends on you people being reasonable, you know. It sort of does. So, you know, it's on your shoulder, so to speak, you know. You're mixing the ingredients that make tomorrow, and, you know, you can sit there and insist that, you know, it can't be, but what if it is? And, you know, then you weren't much of a contributor, were you? With your naysaying and your nitpicking. Alright, I guess we don't need the camera on, and then the Firefox will show up, hopefully. There we go. Alright, so there's another one of these horrible, awful videos by Eugene, whatever. So I figured I'll play it slow, you know, music, you know, just pretty horrible physics. It gets hundreds of thousands, if not some of them millions of views, blah blah blah. This one, I guess, just by the description, is only on 160,000 view numbers because it doesn't sound very interesting. Diffraction interference patterns with phasor diagrams. Like, you know, most people don't know what that means. I don't, you know, frankly, but I guess these are phasor diagrams. You know, but there's, you know, none of it makes any sense. Horrible mush. When a wave, so again, you know, we always have to assume it's a wave, and all the waves are the same, and they all behave the same, and we know the mediums completely dictate what the wave will do, and blah 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 blah. And this doesn't work. So again, they just keep arguing that there's two waves in the double slit experiment. There aren't two waves. It won't work with two waves. The math doesn't work with two waves. There's clearly two patterns. You know, let's go over this one more time. They're just totally unaccountable to the actual facts. They just evade and ignore, and they shouldn't get away with that. The universe of reasonable people should say that's not the fair cop kind of crap. I should be able to fix that. That doesn't look quite right. Well, that didn't fix it. So whatever that is, it's the wrong thing. Well, it's the right thing. It says so. It's not changing anything. Oh, that's the camera, idiot. Oh, there's Firefox. I should be able to make that look, well, it doesn't look much better, frankly, so I'll just leave it there. Guess I could make it bigger, and that would fix it. So I'll make it a little bigger. There. And I can get rid of the extra little dirty bits that don't need to be there. Anyway, where was I? Making the video. Oh, I should use my clean chalk. And put the camera on. Yeah, there. That should help. And then I have to move into camera position. Yeah, that's a little bit of a problem. Anyway, the camera doesn't look quite right in its position. So let's see. So let's see where it is now. Where's it today? So I can go as far as I want over that way, and I can go almost as far as I want this way. It's this top and bottom I always get wrong. So top is somewhere there, and bottom is somewhere down here. Okay. Anyway, sorry. Just, I could have paused. That's what I should have done. But anyway, the pattern. Okay, that it's I'm gonna just use little dots, lines, and then I'll put. Well, I gotta put it over further, or it's not gonna look right. I'll put 5 of them here in the middle, and then there's 3 again over here. That's the real pattern I have to count for. It has these dead spaces in here. Okay, really real dead spaces. I mean, they're really there. They're not a figment of my imagination. They're not just in when I do the experiment. In 99% of the cases, that's the pattern you're going to get. Now, there is one special case where you make the slits so thin that you don't get the 2 patterns because the distances between are so small that you won't see any pattern. But in every other case, this is what you get. And they don't account for it. And it's clearly 2 patterns. There's this clumpy pattern here, and then the little bit pattern. And the simple explanation is that the 2-wave theory fails. And what you have to understand is that there's really 2 distances in here that are the most relevant. This distance and then this distance. And that this big distance has lots of wavelengths in it. And it's accounting for where these things show up. And this small distance has very few wavelengths in it, and it's accounting for this pattern here. And like the single slit, as I've explained, there's a reason why this pattern, this middle blob, is bigger. And it's bigger because it is being controlled by this distance. And that distance is creating a circumstance where the arc of the pattern doesn't start until a little past the center point. And so the real pattern starts here and here, and the light, okay, a bunch of bleeding light ends up filling in this middle part. So you don't see that it's got a gap in it. But that's the real pattern. They don't account for it. They just pretend they can get away with this superficial garbage that it doesn't fit the evidence. It seems a little bit like, it looks a little bit like, and they just jump to the conclusion that they can say it is like, when it isn't. Yeah, turn the camera off before you do that, Gary. Okay, next time I'll remember that.
Passes through a wall with 2 holes. A striped interference pattern is created.
So they show this preposterously strange pattern here. It's not consistent. It isn't the right pattern. I don't know why they're doing it. It doesn't know what it means. Clearly, all these bars stay the same size if you do view it on an arced screen. So technically, the rational thing to do is to understand it's supposed to be equidistant from the point sources if you're going to get a coherent or consistent pattern. And if you try to force it onto an infinite plane, you'll just stretch everything and distort it, clearly. So, in most cases it doesn't matter because you can't see the bars that are really high angles because there aren't enough photons, so they're all invisible. And you're only seeing a tiny percentage of the real pattern in most cases. But this is just, they're not even trying to get the right answer here. I mean, they're not even trying to show you the right pattern. I mean, maybe the pattern, if you use non-monochromatic light, will do this. But again, these waves going in are clearly monochromatic. They're clearly consistent waves going in. So you can't use that argument. This is just, it's just junk.
But an interference pattern can also be created even if the wave passes through a wall with just a single hole.
Okay, well, it really can't in what you're showing, which isn't light, right? I mean, this hardly looks like light going in here. But it won't happen. So in water waves, it doesn't, for any reasonable reason, it never breaks like this if you're putting regular waves in. Now, if you put in waves that are really, really high frequency and the medium can't handle that, then you'll create interference going in. You'll create noise in here. You'll see the noise and you'll shoot noise out. But the noise won't be created the way they're describing here. This doesn't physically happen. Like all of a sudden all these waves start breaking. That doesn't happen. It's just a lie. I mean, it's a complete made-up fabrication. And again, the pattern doesn't do this weird separating length distance thing at all. So this is just more inconsistencies in the story. Water waves will do this a little bit where it spreads this way, but that's only because of the only diffraction there is at the end of the impediment, because it's friction that's causing the round waves in the single slit with water. It's not, it's friction. And water sticks to each other, so the water bends because there's friction on the sides and the water's slowing down. And then sometimes it can stick to the walls and it breaks. Little wavelets will come off of the edges. But that's it. It's not an interference pattern. La 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 la. Slow, slow, slow. We'll speed it up.
To understand why this is the case, we need to understand that each wave can be thought of as the combination of an infinite number of smaller waves that spread out in all directions.
Right, which makes absolutely no sense to anybody rational, right? And this doesn't work for water, and it doesn't make it good for a good explanation for anything. So, an infinite number of little wavelets are popping up out of the wave to create the next wave, and it's like, yeah, sure. Doesn't fix anything. I'm just saying mathematically it doesn't work. It won't make the double slit pattern. There's no way to make it force the waves into the silly positions of being where the surfaces are, right? So I need to make my arrow thing sometime. I mean, it's worth just emphasizing. Huygens, the principle of this infinite number of little wavelets, will not produce the wave centers in the place you need them to be to make it mathematically possible for this theory to make any sense. So, not supposed to do that, Gary. Well, who cares? So, this simple argument is that, let's say I had a single slit. These are the waves you should expect. Okay, nothing complicated. Okay, waves come in, waves go out. Same thing, no interference. And when there is, in the light experiment, the center of the waves where the math works, this math works, is one wave has to be here and one wave has to be here. Now, obviously, the wave wouldn't break right here in the center for no reason. And it certainly wouldn't go through the surface, okay, to start the wave. So it won't work. The wave center, okay, is in the wrong place. And then certainly in the double slit, it becomes even more apparent. The math that works has the 4 point sources in it, the 4 waves. And so now your waves have to be in these ludicrous positions where the center of the wave, right? So it breaks right in the middle of the impediment. So it goes through the impediment and then breaks in the middle of it. And obviously it breaks in the middle of the opening, which is just makes no sense. There's no logic to it. Huygens doesn't allow you to move the waves this way and move the waves this way and reorder them and all this stuff. And Huygens is saying, what she's saying is there's waves, and one wave is made by an infinite number of little waves popping out of this wave. So even though the wave is only 1/2 of a millimeter or something, yeah, there's an infinite number of little wavelets that pop out and make the next wave. And they have to say infinite number because the only way they can make this a flat line again is to make it an infinite number of little humps. So all the humps points are all the same place. I mean, it's a silly theory. It's a silly answer. It's not a good explanation, okay? And it's not good for your brain to even imagine it. And it's not good science. It's obviously flawed and malformed as an explanation. So this is all very whatever. It's not even that pretty. But
When the wave hits a barrier with a small hole, only the portion of the wave that is directly behind the hole is able to pass through.
so now the portion, if there's an infinite number of them, what does that even mean? It doesn't mean that one little lump comes through. I mean, again, and how did it get round? The whole point of having an infinite number is to create straight lines again, right? So you have an infinite number, so your straight line wave, okay, becomes another straight line wave. Now all of a sudden she's turned it into a bunch of lumps, okay, and now I can have a lump that goes through the slit. Well, that's not what we see in water waves, and it's certainly not what you could expect in light. So again, it's just so fake and phony and bullshit. It's not even doing anything. La 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 la. So now all of a sudden the straight line wave has turned into this thing, which isn't Huygens, because Huygens says there's an infinite number of them and they're still straight line waves. And Huygens doesn't provide any reason why they turned into lumpy waves all of a sudden when they got to the slit. Huygens doesn't say, hey, when you get to a slit, the infinite waves do something infinitely weird. There's no explanation for why the Huygens principle that was making the wave propagate all of a sudden encounters a slit and all of a sudden Huygens turns into something else. There's nothing else for it to turn into. It's the same principle. That's why it's called a principle. And it's not consistent. You have to change the rule somehow. And what's the reason for the rule change? Well, there's no mechanical reason for it. It's just made up. They can draw it phony, so therefore they can make it work. And you don't care, right? You don't care that it's not the truth.
This is why waves spread out when they pass through a barrier with a small hole.
So it doesn't explain why they spread out at all. They're making this wave made another flat wave in front of it by creating an infinite number of little lumpy waves in front of it to create another straight line. It doesn't explain why it comes out of here bowed. And again, even if it did, it's the wrong location mathematically. It isn't going to make any pattern. See, now they're showing the single slit and they're just showing one wave coming out. That's not interference. That's not going to make a pattern. So that's not going to work. I mean, they just change the rules, right? It's just anytime they want. 1 minute it's making a pattern, now it's not making a pattern.
If the hole is bigger, then more of the waves are able to pass.
Okay, so that's just more nonsense, right? We're talking about an infinite number. Bigger doesn't mean anything to an infinity. So that's kind of silly right there, right? And we know the pattern is there whether you have a narrow slit or an open slit. You're just making the bars bigger or smaller, right? Technically. And that's it. By the width of the slit, you're just saying how many wavelengths fit in here. And again, it's about the wavelengths of distance. It's about how many vectors you can put together from the two slits. So the wave has to be over this edge of this slit. There can't be these little waves won't make the pattern. I'll say it again, they won't. They won't mathematically ever get the right answer.
Through, and these waves have the ability to interfere with each other.
So there's not even a coherent explanation for how they're interfering with each other when their centers are on these corners. So again, this drawing has nothing to do with reality. Nothing. Somehow, see, they've just totally exaggerated the wave going out this way because they need to make it go over this surface. And then they flatten the front. You see the way they flatten the front? So they've totally just distorted it. They've made this part of the wave going out. Well, sorry, you can't see that because my mouse doesn't show. Well, anyway, the waves going sideways, they've emphasized, and then they de-emphasize the ones going forward. They flatten them out. That's the only way they can try to push the wave over the surface, because they need the center to be the distance between the two surfaces. And again, they're creating two waves. How in this image? There's no explanation of how those two waves interfere with each other, except for the fact that they've completely distorted them. So again, this doesn't happen.
To understand the interference pattern that...
there's no understanding it. Like I said, if you do water waves at a regular speed, none of this happens.
These waves will produce, let us first consider the interference pattern created by two small holes.
And now the completely incoherent pattern, and the two small holes where she's not showing anything going through the holes yet, so we'll get to that, I guess.
The waves coming out of each of the holes can be thought of as sine waves that travel out in all directions.
So again, the waves that come out, there's one arc here. So how again are there two waves?
The waves, as seen along a one-dimensional line, can be thought of as just a single sine wave.
Yes, and that's not going to be able to interfere with itself, so you're out of luck there. That's not going to make interference. It's not. At
any given point.
Yeah. So now she's back to two waves again, right? So this illustration won't work. The double slit needs 4 waves for the math to work, to make the complex pattern. So again, just horseshit. So 2 slits make 2 waves, 1 slit makes 2 waves. It's complete nonsense.
The interference pattern formed by the 2 waves from the holes can be thought of as the sum of the 2 sine waves along the intersecting lines coming from the 2 holes.
So again, that's only going to get you half the pattern, right? So these vectors are correct in the sense that, but they're in the wrong place. So the point sources that work are the distance from the 2 outside distances. The 2 furthest away point sources create 2 vectors, and the 2 inside sources create 2 vectors. And then you have 4 vectors. And where those 4 vectors are in phase, you'll have a light spot. Where only 2 of them are in phase, you won't. And that's the double slit pattern. See, the inside, because they've exaggerated, had these little tiny slits and this big outside part, you're not really getting the idea how, yes, the 2 inside vectors are going to create, much fewer points where the 2 much bigger blobs where the two intersect at the same phase. And the further out ones, the ones that will be further out, are going to create a lot of tiny places, on, off, on, off, on, off. And you don't get any feel for that because of the way they're illustrating it. But it clearly can't be explained with just two sources.
When the peaks of two sine waves occur at the same time, we say that the two waves are in phase.
Yes, so this is the point so if the simple explanation is just scatter off the surfaces. There's electrons on the surfaces, the photons are broken, the composite photon object is broken, has its pieces scattered. The scattered pieces recombine. When they're in phase, they become a photon again. When they're out of phase, they're not a photon. Simple explanation. No destructive anything. Just a bunch of, well, you could argue that the photons are destroyed when they're going through by the electrons on the surface, but there's no destructive interference. You just remake a photon or you don't.
Since both sine waves are created by the same original wave, which passes through both holes at the same time.
So again, implying that a photon does that.
The two sine waves are always in phase at the moment when they exit the holes. The two sine waves are also in phase for any point for which the distances from the two holes are equal.
So again, this is not recognizing the fact that that is the interior diffractions, which is only happening in 1 millimeter of space. For example, in the double slit experiment, the whole experiment's less than 1 millimeter across. And the fact is all the stuff going in, any scatter going in, or any waves going in, would only be going into 1 millimeter of space. And so that doesn't mean anything. It's such a tiny amount of the experiment that's sort of a fake source, in the sense that the real starting line for the two slits is at that millimeter distance. That's where the pattern really begins.
The distances from the two holes will no longer be equal if the angle of this yellow line changes. The more the angle of this yellow line changes, the greater the difference in distances from the two holes.
And again, it can just be understood that exactly how many wavelengths fit in between the distance will tell you exactly how many points there will be where you can have these possible two vectors that will combine in phase or out of phase. By displaying it on a flat plane, the obvious flaw is that the last node will be an infinite node, technically. And you've just stretched them all. You've made them all disproportionately sized. Now, their math doesn't predict that, so obviously it only matters if you pay attention and you actually measure any of this stuff, which they don't do, because it's not about verifying it to be true. It's just about saying it looks a little bit like.
The greater the difference in the distances from the two holes, the greater the difference in the phases of the two sine waves.
Right, so they can be way behind. They can be a whole wavelength behind, right? They can be 2 wavelengths behind, 3 but that's the whole point. That's how you make a photon, as a frequency. So you want some photon wave, the third wave from one to go through, and the first wave from the other side will be, can go way over here. It takes it a long time to go all the way over to the other side. And the third wave from the other one is taking the shorter distance, so it could be first. And so you're just putting the bullets back in order.
The strength of the interference pattern at each point is the sum of these two sine waves.
Which doesn't even mean anything, the sum of the sine waves. She's just saying whether or not they're in phase or not. They're on or off, on, off, on, off. 2 ons make an on. You can't even say two offs make an off, right? Because because the water's doing this thing and the light's not turning on and off. In the water experiment, the place where you see something or you don't see something is dependent on how much action there is, how much on-offing they're doing. It's really blinking. It doesn't do that with light. Light isn't blinking.
A sine wave can be represented graphically like this.
Can be. Yeah, but why would you do that? Oh, no real good reason. Now, no evidence that anything in any fluid is ever doing all of this stuff. No evidence, none of this is happening. So again, this is what are they representing here? La 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 la.
The sum of two sine waves with the same frequency and phase can be represented graphically like this.
And again, what does this representation show? It isn't actually what's happening, so what's the point of it?
The sum of two sine waves with the same frequency but different phases can be represented graphically like this.
Oh, it's just so helpful. Yes, so that tells you why there's an on or an off, why there's a photon you can see and a photon you can't see in this pattern. No, it doesn't tell you any of that. I didn't play this video this far through. This is like really pointless. So I guess those are the phasor diagrams. Oh, here we're back to real stuff again. All right.
In the case of the sine waves coming from our two small holes, the two waves have the same amplitude and frequency, but different phases. As the angle of this yellow line changes, the difference in phases increases.
Yes. It gets more and more out of alignment. So instead of having a 200 megahertz signal, you have a 400 megahertz signal kind of idea. Yeah. But as you're getting there, if you're getting to the 400 where you're right in between the two, you have a bunch of stuff where it's kind of broken. You know, the distance between two waves is 400 nanometers here, and then it goes to 200 nanometers, and then it goes to 400 nanometers, and then 200. You know, it has a bunch of, well, more like 4, 3. Yeah, then 5, then 3, then 5, then 3.
As the difference between the phases increases, the sum of the two sine waves also changes.
This is really quite useless. So, let's see if we get back to something that has something to do with waves.
This is why a striped pattern is produced.
That's, yeah, well, so we know it's not a striped pattern, and certainly not striped this way in any way. So this is just a mess. You know.
Now, instead of two small holes, let us consider the case of just a single large hole.
So here, when they do the two slit, they make the openings infinitesimally small. And then when they do the single slit, they make it preposterously large. Yeah, right, great. So now they're doing their whatever, the Huygens pretending that there's a bunch of different waves coming through when there, you know, there isn't. A bunch of different little out of phase things. Potentially out of
large hole
phase.
Can be thought of as a number of small holes that are right next to each other.
And so all they're doing is pretending that this one is at this position and this one is at this position. And those are the only two that are going to be relevant. The rest of them are going to be irrelevant because the less distance you have, the less effect you can make. It's only with distance you can have enough wavelength distance to make a pattern.
A sine wave comes out of each of these holes, and these sine waves add together.
Alright, well, this is really, it has really nothing to do with how you would figure out the vectors that'll recreate the phase being matching versus not matching phase. We just jump ahead a little.
One of the sine waves is smaller than the one before it.
Well, that's just too cute.
This means that the amplitude of the wave becomes much smaller as the angle of this yellow line increases.
Yes, but again, you're still talking about this wave and this wave are the only ones that are going to show you any real difference in their phase because of their path length difference. There's no path length difference between the ones the infinite number of the ones right next to each other. I mean, if you're infinitely close to something else, you can't really have a path length difference. Well, whatever, this music is just makes you want to kill somebody. Anyway. So here they go. They just keep adding more and more and then try to make all those waves go to 1 point and blah, 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 blah. And it's just a bullshit way to illustrate the real fact, which is the only ones that are going to be out of phase are the ones that are the furthest away from each other.
The angle of this yellow line changes. The differences in the phases of the sine waves increases.
Yeah, but the only ones that matter are this one, the one at one end, and the one at the other end. They're the only ones where you're going to see the difference because the rest of the difference is going to be irrelevant. So again, it's just a way for them to turn one wave into two waves. And again, they won't use the same analogy. They won't use this same description to show you what the two single slits and the double slit are doing. There might be some reasons you might believe this crap. That's what happens. Well, then why don't they do that in the double slit? They don't apply the same theory when they do the double slit math. Oh, anyway.
As the differences in the phases of the sine waves increases, their sum can be represented as shown.
Their sum, the sum of the infinite number of bullshit, and the only thing again that's going to matter is the distances, the furthest distances. So anyway, that's all this is really saying. With this distortion. And I don't think there's anything else in here that's worth more figuring.
Reality, and in the other videos on this channel. Please subscribe for notifications.
Well, let me see that part. So again, they have the single wave coming out again for whatever reason.
If the hole is large relative to the size of the wavelength, the wave does not spread out, and instead looks like it is traveling in a straight line. Much more information is available in the...
Yeah, well, that's because the wave isn't... the portion of the wave interfering with the surface is so small that you can't see it because of all the light that's going through the center. Yeah, that's the reason...
Video titled Waves, Light, Sound, and the Nature of Reality, and in the other videos on this channel.
The nature
Please
of
subscribe
reality.
for notifications when new videos are ready.
The nature of reality. It's a mechanical universe, and just simple things are happening. There's nothing complicated down at the bottom. But anyway, alright. So, we'll call it a video, and just say if, I can't stop you from falling for jargon, but that's all that was. It really had nothing to do with reality. Believe it or not.